Hi everyone, I'm Liang from Peng Lab. In this section, I'm going to introduce our work on enabling an auto-configured NFD at edge. So NFD is a software forwarder for NDN. If you want to run your NDN applications, normally you set up, you also run NFD, which gives you the NDN network. And to run NFD, you need to configure your network environment. And previously, it requires a lot of manual configuration. For the first part of the manual configuration is security. You have to configure NFD and tells it who you should trust to add the route. And this part is elaborated in the previous section, so I will skip this part. In addition, you also need to set up face, which provides the connectivity between your machine and other machines. And also you have to add route, because in NDN, you have to use name-based routing. And so you have to tell the forwarder how to forward the packets based on the names. So here is a concrete example. Initially, you run NFD. There are two machines. On the left side, there's a consumer. The right side, the producer. Assume they are within a local network. Initially, you have to run NFD before you run your NDN applications. And for NFD, initially there's no fib entry, so your fib table is empty. If you just directly run your NDN application, the forwarder NFD does not know how to forward the traffic, so it will send a NAC back. So to set up a face for manual configuration, you can run this command, nfdc face create, and the remote URL, and also local URI. So for the remote URI, you have to figure out the address of the remote peer. So after the command, a face will be created on the NFD. And next, you also have to add the route. You can also use nfdc route command to add the /book and the next hop in your fib table, so you can add the /book in this example. So after these two commands, you already set up a workable network environment. You can see this configuration is non-trivial and it requires a lot of knowledge of NFD. And for this red box part, that's how our work is about. We want to make it auto-configured so we can reduce the overhead of configuration. So how can we achieve auto-configuration in NFD? Our idea is that we use self-learning. And this slide, I will briefly introduce how self-learning works. So the first question for self-learning is how to discover data when you have no routes, right? What your NFD should do. So the answer is self-learning will broadcast interest to all potential faces. Self-learning has an assumption that if the data is reachable in this network, it can be reached through broadcast. And the reason broadcast works in NDN is because NDN can detect topology loop, so it does not need to worry about loops when you do broadcasting. The second question is how to set up a face. Initially, by default, we have multicast, well-known multicast face. And we can throw the multicast to retrieve data, but multicast does not perform well in wireless scenarios. So self-learning will learn the unicast face on the data reception. And the third question is how to avoid broadcast overhead. Although broadcast is effective, but it generates a lot of redundant traffic. Self-learning will set up routes towards specific face on data reception. So the subsequent interest will be forwarded towards the specific face. This work was originally proposed in 2017, and in this year we implement it in NFD and make it work. So next I will use a concrete example to demonstrate how self-learning works. So assume we have 3 machines, 1 consumer and 2 producer in a local network, and by default they're connected through multicast face. When you run NFD, this is the initial setup when you run NFD. The consumer send the interest to the NFD, and the interest will be broadcast first, and the interest will reach the producer. Let's assume both producers, they have the data, and the data will be retrieved back. And on data reception, the consumer will create 2 unicast faces towards either producer, as well as create a fib entry /a and point to it. So after this initial interest data exchange, the consumer NFD will self-learn the face and the route without any configuration. And subsequent interest will use the best route strategy because there are already routes, and the interest will stick to one producer first. If there's a retransmitted interest, it will be forwarded to the alternative path. And we also add the producer failure handling in self-learning. If the current producer fails, it will generate some NAC back, and that path will be cleared. So in this picture, you can see if the producer fails, there's only one path left. So the upper path will be cleared. So the interest can still find the alternative path to the producer. Okay, so next, it's hands-on time. I will show you how we implemented in the latest code of NFD and how it works with a simple example. So here are 3 machines. The setup is exactly the same as I described in the slides. You can see on the right side, these 2 consoles, they represent 2 producers on a different physical machine. There are 2 virtual modes. And what we can do is we start the NFD first. And okay, so NFD is running. Okay, so let's run a NDN producer. Like let's run NDN Peng server, let's say /a. So NDN Peng server /a. So you can see on the right side, these 2 producers are running NDN Peng server on the /a. On the left side, it's the consumer on my laptop. And the consumer and producer, they are connected through a common home router. And let's just run NFD start. Okay, we can check the route first. Initially we only have one route, so that's the local host. We have no routes towards /a, right? And previously for manual configuration, we have to set up a face towards both of the producers and add a route /a, so the NDN, then we can NDN ping /a. But right now with self-learning, let's say what happens if we directly ping NDN /a. You can see the first interest, it reaches both producers, right? Interest received, and it will generate data back. And after the first interest data exchange, the consumer will set up a face towards both producers and announce the route /a to both of them. Then subsequent interest, they will stick to one producer. And let's see if we kill this producer, what will happen. So just fill this producer. So we can see the consumer is still retrieving data for /a from an alternative producer. This is because we have the failure handling mechanism. It will automatically find the alternative path. So what I demonstrate here matches exactly what I introduced in the slides. So we just stop and go back. So the conclusions here, with self-learning in NDN, consumers can automatically discover and retrieve content within a local network area without any configuration of face or routes. So that's it. Thank you for watching.